Wednesday, May 27th post. So I know you guys are working or may have finished your sources of water presentation. And so this one will just add a little bit of information because part of the presentations was you were taking down information from other people's PowerPoints. In this case, like we didn't do that because we're not in class watching the presentation. So we're doing this a little bit differently. So this will give you some information on the sources of water with a little bit of detail that you would have gotten from other people's presentations. And then there is an assignment for you guys to work on afterwards. So I'll give you guys some of the details in this video, and then I'll explain the activity that you have to do. So just going over here. So you can see that fresh water comes from a lot of different areas. Fresh water can be found in lakes, ponds, and wetlands, streams and rivers, groundwater, glaciers, and drainage basins. So we will eventually get to what drainage basins are. That's what has to do with your lesson, but that'll come at the end of the video because I'm just sort of going through all of your different notes for this. So lakes, ponds, and wetlands, I'll let you guys read those on your own. Just one of the bigger points that I've highlighted are all wetlands have one characteristic in common, and that is they're saturated with water all of the time or most of the time. Wetlands provide habitats for a large variety of plants and wildlife, so it has more information there. I just wanted to highlight some of the key points from this lesson and what you would have gotten if your focus was lakes, ponds, or wetlands during your presentation. This should give you information on all the different sources of water in a more condensed form. Streams and rivers just gives you some information, but I will highlight the differences between rivers and streams, even though they are very similar. These are the differences that separate them into their two categories. So that's the speed of the water flow. Rivers flow much faster than streams. The temperature, the clarity. So what that means is if you looked down into a stream or a river, one will be much clearer to see through and one will be a little bit murkier to see through. The banks, so the sides of the river or stream, are different, and then the bottoms are different as well. These differences affect what types of plants and wildlife can live in them. Fish and other animals tend to live in faster flowing water, which is why you'll often find fish in rivers as opposed to streams. When we talk about groundwater, we've already touched on this a little bit, but precipitation that falls on land and sinks out of sight, and it goes into the bedrock where it pools and stays there, and then you have to drill into the ground to get to those pools of water to access them, which we talked about with the Guelph water station. This is what they had to do to be able to access all of the groundwater beneath them. We move on to glaciers, and there's some examples of those here. There are two types of glaciers. There are alpine glaciers, which you'll find on mountaintops, and then continental ones, which you find in this example here of Greenland, which is basically like a giant glacier. It's frozen most of the time. And then again, it's found in areas where it is so cold that snow remains all year. So that's why you really only see them on the poles, like the North and the South Pole, and you don't really see them floating anywhere else really unless they've broken off of their main bulk of glacier. Just glaciers and the water cycle. So this is what North America used to look like before everything started melting. We started getting a little bit warmer. And so this is just some information for you guys to look at as well. Glaciers and global warming. So I won't get too much into this, but just some of the points. In the last 100 years, the temperature of the Earth's surface has increased by half a degree over the last 100 years, every year kind of thing. This means that the glaciers are melting at a faster rate, and that could cause flooding because normally ice is a solid, so it has a finite amount of room that it takes up, but as we know, when it melts, it takes up more space, it takes up more area, and so that's bad, obviously, when we have large ice chunks. If we suddenly have those now as a liquid, those are going to take up room, and some parts of the globe may go underwater if that were to occur, and if that is going to happen. So this is just something interesting. So the glacier is a source of water for Alberta and the prairies in the western, but this is the receding Athabasca Glacier, and it's receded 1.5 kilometers since 1843. So they just have markers that show where it was originally. So this is where it was in 1992, and you can see it all the way back here now. So it's receded, or it's melted quite a ways back, And if that continues, obviously, eventually this glacier will be no more kind of thing. When we talk about drainage basins, which is what our activity will be based on, so all fresh water on Earth's surface and groundwater is part of a drainage basin or a watershed. That's just another name for it. It's very similar. The area of land that drains into a body of water, such as a river, pond, lake, or ocean. There are many small ones within a larger basin. So what that basically means is that all the fresh water on Earth flows into a larger body of water. So like a lake would flow, like a river would flow into a lake, and that lake flows into the ocean just as a small, like, one-step process kind of thing. A divide separates one drainage basin from another. So an example of this would be the Continental Divide. And this is an imaginary line that sits on top of a mountainous summit and divides the continent into two main drainage areas. So most of our water will either flow into the Pacific Ocean or into the Atlantic Ocean, with some of it going to Hudson Bay and stuff like that. But for the most part, we have two main drainage areas with some going into smaller ones. So this shows you, again, like a map of our drainage basins, and it just blows it up here. So here's Alberta, Saskatchewan, and Manitoba. So these are drainage areas contributing to Manitoba. And then we go on to here. So in this one, this shows you all of the Canadian ones, and this shows you the main ones in Manitoba, Saskatchewan, and Alberta. We have 8 managed drainage basins that are found in Canada. Again, the top 2 here being the Arctic Ocean, the Pacific Ocean. We also drain into the Hudson. We also drain into Hudson Bay, the western side of it. We drain into the Mississippi River. We drain into the southern Hudson Bay. We drain into the eastern Hudson Bay. We drain into the Great Lakes through the St. Lawrence River, and then, of course, the Atlantic Ocean. These aren't in order of size. These are just the order that I put them in. I misspoke earlier in this video, but these are the 8 drainage basins that our freshwater will lead into or drain towards. The last one is a runoff. So an additional source of fresh water is a runoff. We saw this in our water cycle lesson. This was one of the other points that we had. And so runoff doesn't sink into the ground or evaporate. It flows across the Earth's surface. So it's kind of like a river or a stream, but in a smaller scale. And a runoff is affected by the ground material that it's on, the amount of rain that it gets, the length of time that it rains, the slope of the land. So if it's a pretty flat surface, the runoff will move pretty slowly. If it's more of a mountainous, elevated surface, then it'll drain a little faster. The vegetation around it, because the more water vegetation needs, the smaller a runoff would be, and then the amount of development. Obviously, if it's in a city, it's not really going to be there. But if it's a maintained area like a farmland or anything like that, it'll flow a little bit easier. That's pretty much Cole's notes of the information from those topics. You don't need to do anything with those. The stuff in bold is the most important if you're keeping a notebook while you're at home, just with some of this information. But other than that, that's all that we really needed to talk about. This was more informational. But our activity is based on the drainage basins and the idea that all of our fresh water is flowing to larger bodies of water. So again, you can ignore this first part because we're not presenting to the class or anything like that. But on page 31 in the textbook, which I have available for you, and I'll show you that in a second, you have to do parts A and B, and then analyze questions 1, 2, and 3. Again, ignoring the parts about the presentations. You can send those in to me whenever you have them finished or whenever you are able to. So, page 31 of our grade 8 textbook. If you guys have some of these at home, you can. I didn't encourage you to take them home because I was going to give you access to them, and it's just an extra load that you have to take to and from school. So here, I'll zoom in a little bit for you. So you have to rank these drainage basins. So here are the drainage basins. So the Pacific, the Arctic, Hudson Bay, the Gulf of Mexico, which when we talk about the Mississippi River as one of our drainage basins, the Mississippi River eventually leads to the Gulf of Mexico, which is a part of the ocean in a small, it's almost like their version of Hudson Bay. It's just a little bit of a different size. And then the Atlantic Ocean. So what you have to do is you have to rank them in order from size. So area in kilometers, which it gives to you. So it gives you the area from the largest area to the smallest area. And then you're going to look at the mean discharge. So that just means the average discharge from the largest volume to the smallest volume. So it's already calculated that here for you. So you have to order that again from 1 to 5. And so with the analyze part, you have to explain the difference in the ranking. So why a ocean that takes up a larger area may not be the largest drainage basin. So in terms of area, it may be the largest, but in terms of amount of water that gets drained there, it might not be the largest. What would the explanation be to explain that difference? And then to which coastline does most of Canada's water flow? Does it flow to the north, the east, or the west? So basically, if it's going to the Arctic or Hudson Bay, it's going north. If it's going to the Pacific Ocean, that is our west. The Atlantic Ocean is our east, obviously, and then the Gulf of Mexico is south. It doesn't even give you that as an option, so that one you just exclude from your calculations. And then what percentage of total flow goes in this direction? So once you've determined if the most amount of water flows north, east, or west, what you're going to do is you'll just add up those total amounts and then divide it by the total amount of water being discharged into all of the drainage basins. So basically, you'll get your total by adding up all 5 of these areas, and then you'll add up the total of north, east, or west, and then divide that, kind of like you're figuring out a percentage in math. So if you got this amount and this was the total that it was out of, you're figuring out your mark on that test. If you have any questions about how to do that, I can explain it in more detail if you send me an email. But other than that, that will be your lesson. So mainly informational, but this is your task, talking about drainage basins with a little bit of a small assignment. Best of luck to you guys, and I will have a new assignment for you on Friday.